Welcome people to my new video. Apologize for my bad English. In this video I will talk about the Riffle Shuffle. And the Riffle Shuffle is a card shuffling technique that casinos use to shuffle the cards. Now there are many ways to shuffle. You have the Riffle Shuffle here, the Riffle Shuffle, smooshing and overhand. In this video I will talk about the Riffle Shuffle. Now I will talk about, one deck and 52 cards, but of course the casinos use an 8-deck shoe. So here, one deck, and here 1, 2, 3, 4, 5, 6, 7, 8, 8 decks. One deck, 2 decks, 4 decks, 6 decks, and 8 decks. Evolution Gaming use an 8-deck shoe. Now, reasons to shuffle. Why do casinos shuffle the cards? Now, there are two reasons actually. The first reason is to get some variation in the games, can generate multiple games for the players, and otherwise you would get 2 games only, from left to right and from right to left. The second reason is unpredictability. Casinos try to make their games as unpredictable as possible. Unpredictability is actually the same as randomness, or they both go hand in hand. And I will demonstrate this with this list of numbers, or this box of numbers. So I will do this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then here 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then I will ask you what's the next number. You will say 21, of course, not 50, not 66, not 88. But now we will do this. I will start here, 23. And so I ask, what's the next number? You have no idea, right? Because it was random. And that's why casinos shuffle the decks. They want a randomized deck of cards. That's the end goal. So here you see 4 cards, from left to right, and now we go from right to left. And so you will say, this is an 8, then a 3, an ace, a 7. Now I shuffle the cards. You have no idea what I did. Now you have no idea what the cards are. So now we need a more scientific definition of randomness. And for this I need to teach you, what permutations are and the uniform distribution. Right? So remember these cards. Now we will use colors instead. So 7 is gray, ace is black, 3 is orange, and 8 is now red. This is a permutation because it has some kind of order. It's first gray, then black, then orange, and then red. And this is just an example. Here you see 3, 1, 2, 3 permutations. They are not the same. Here it's first black, then gray, orange, red. First gray, black, red, orange. First gray, black, orange, red. Now for an deck of 4 cards, there are 24 permutations in total. And that's randomness, because every permutation, every permutation has the same chance of occurring, the same chance of falling. So this permutation has a probability of 1 over 24, the same as this permutation and the same as this permutation. So we get a uniform distribution. That's randomness. You see, all 24 permutations have the same probability, 1 over 24 or 4.20% of occurring falling. Now we go back to the Riffle Shuffle. Now one Riffle Shuffle will also create some kind of distribution. This is the Riffle Shuffle, so you take the deck of cards, you cut them and you divide them in 2 piles, one in the left hand, the other in the right hand, then you interlace them together. That's one Riffle Shuffle. The deck of cards had already some kind of order, some kind of permutation before we start to shuffle. And so this permutation is the starting position. We also call this the identity. Now there are 3 ways to cut a deck of 4 cards. Cut number 1, cut number 2, and cut number 3. Here the cut is below the first card, the cut is below the second card, and below the third card. These are all the permutations, the permutations for cut number 1, cut number 2, and cut number 3. Now there are 14 permutations in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 3 are similar. So with other words, there are 14 permutations in total after one riffle shuffle. And that's the left box. But there were 24 permutations in total with randomness. And that's the right box. So, and as you can see, some permutations have a higher chance, then some permutations have an equal chance, and some permutations cannot fall at all, and you have 0% of falling. Because here, orange falls before red, but that's impossible with one shuffle, right? Here, orange cannot fall before red. So that's why these permutations are not possible. Right? So after one riffle shuffle, we get a non-uniform distribution. You see here, some permutation, in this case 1, will have a higher chance. Some permutations will have an equal chance, and some permutations won't fall at all. That's not randomness. This is randomness. So this means that with only one riffle shuffle, we are unable to get a randomized deck of cards. We need more shuffles. So the question, of course, is how many times do we need to riffle shuffle to get a new randomized deck of cards? So this distribution is different than this. And they are not the same. So there's like a distance between them. And in statistics we call this the statistical distance. The statistical distance, or in other words, the total variation distance, TV. This is the mathematical formula for every permutation. This is x here. You compare 2 distributions, you see what's the difference, take the absolute value, you add them up for all the permutations and you divide by 2, and then you get a number. So here you see the numbers. If we do not shuffle, then it's the most far away from a new randomized deck of cards. So that's 1. And if it's 0, of course, then there is no distance anymore. Then they will look similar. They will be exactly the same. And so then casinos use, a threshold, let's say 0.5. And the first time it goes below this threshold is around 7 shuffles. So that's why you need to shuffle one deck of cards, and not 4 cards, one deck of cards, 52 cards, 7 times. The casinos use an 8-deck shoe, and there are repeated cards, and things get very complicated.